Hi, everyone. My project is called Predicting Comment Removal from Our World News. And the goals are to predict whether user comments will get removed from the World News subreddit, and in doing so, create less work for users and moderators who report and review these comments. I first perform EDA, use that to inform my feature engineering, and then perform modeling using a TF-IDF versus word embeddings framework, which I will define later on. In addition to just text features, I also thought that other factors might help predict comment removal. So for each of these models, I look at the effect of using just the comment text versus also adding engineered non-text features to my models. Out of about 800,000 comments, only 3% are removed, which makes for a pretty extreme class imbalance in my data. I first look at word importance in the comments themselves. As you can see, although they share a few words in common, removed comments also feature a lot more profanity and prejudice-oriented words compared to intact comments. I then looked at non-text features, and one question I had was, do responses to removed comments also get removed? And it looks like 45% of first-level responses also get removed themselves, which is much higher than the overall 3% rate of removal. So to account for this, I flagged responses to remove comments up to 5 levels and added those to my models. Another question I had was, are moderators more likely to punish repeat offenders? That is, are they more likely to remove comments from users who have a history of posting offensive comments? And it looks like while 8% of users posted at least one removed comment, 28% of those users posted more than one removed comment. So to account for that, I calculated the proportion of previously removed comments for each user and comment date. My TF-IDF framework uses 4 models, including a baseline dummy classifier to compare against other models, and a few different sampling and n-gram methods, and F1 precision and recall as my evaluation metrics. TF-IDF measures word importance based on word and document frequency. My results using just text features imply that my model is good at predicting comments that should stay, but not as good at predicting comments that should be removed. After adding my engineered features, I get a slightly higher weighted F1, but much higher F1 for the positive class, meaning my model is now much better at predicting comments that should be removed. My second modeling approach uses word embeddings, which transforms words into vectors so that words with similar meaning also have similar representation in the vector space. And in doing so, helps capture the contextual meaning. I use a pre-trained embedding on Wikipedia data using a CNN model. For non-text features, my results show that adding in the context of words helps us better identify comments that should be removed. When I add in non-text features, my model ends up being the best model overall, and my weighted F1 is the highest, as well as my F1 score for the positive class. So implications mean that word importance doesn't tell the whole story. As we've seen, the contextual meaning behind words and other features also play an important role in predicting comment removal. And adding other user data, if available, might further increase predictive power. Future directions include experimenting with other types of embeddings, finding user account data if available, fine-tuning hyperparameters, and experimenting with other models. So that concludes my presentation, and thank you.